And luckily in this, it does it pretty quickly. And how it's able to do that is this function that I have here, where, you know, a lot's going on here, but essentially it's doing the calculations necessary to get these individual values here and then update each cell, right? Each run one at a time over a period of time, or in this case, epochs. So once we actually get to the bottom here, it takes in those numbers, and that's where we're going to access my table again and use these member functions here to kind of manipulate the exact cells that I'm looking for. So in this case, we're manipulating current epochs, num co-op, and num defect, right? So that's what you're seeing here being changed over time if I hit play. All that's being changed right now are just these cells right here individually, epochs, co-ops, and defects. And so, yeah, I guess the last thing that I have to highlight is how it's getting this interaction with the text box here. And I'm just utilizing another web tool here, the text area, where it interacts with the actual table. So I can get any information that's getting put inside of this text area, and I'm able to extract it and just run with it within my table when I have to set up that whole table. So yeah, hopefully that wasn't too confusing, but I guess just the big takeaway that I wanted to get just to show from all of you is that web tools, even though I guess right now there isn't an empirical queue, right? There's certain features that aren't in empirical that may change over the periods of time, right? But we can still actually take what's already inside the STL library and kind of combine it with the actual empirical web tools, and we can create an application like this. So yeah. If anyone has any questions, here, but yeah, that's all.
Awesome, thank you. That was really great. Yeah, do we have any questions from the participants? I have a question.
Yeah.
I'm wondering, in kind of as the process of building something more complex with the empirical web tools, what was like the biggest challenge or stumbling block that you had?
I guess in the sense of just like this project as a whole, or just like web tool specific?
I guess specifically with the web tools, but maybe more broadly too.
Yeah, so I guess, or at least one of the big challenges, since like I said, we're not making this so much specific towards this simple PD world or the prisoner's dilemma. We want to make it pretty versatile with many other runs. So I guess one of the things that was a challenge, it started getting easier over time, but just one of the challenges to learn is how we can actually like manipulate a table, even though we don't know what like exactly the table is going to look like from the beginning. So actually taking in that user information, I don't know if you remember, but we had a whole discussion on configs, right? Taking information from a user. So essentially just taking in information from a user and trying to create a table like on the fly, rather than already knowing in your head what the table's going to be. That process in its own, I mean, it took a little bit, it's starting to get a little bit easier, but yeah, I guess just that whole idea of not knowing what's coming at you and just working with the data that you get.
Are there any other questions? All right, then thank you, Juan. And next we'll move on to Sara. And it's actually a really nice transition here, because Sara's going to talk a little bit more about how, like Juan mentioned that like there isn't currently like a tool that's been refactored out to be in the library with the queue that he's been working on, although someday we might be able to do that. And Sara's going to talk a little bit about some of the tools that she's been custom building into the library so that people can just grab them and plug them into their web application. So go ahead, take it away.
Sure. So I'm going to share my screen real quick. So I started out like with the goal of the project of kind of revamping this config panel that was on like Emily's, one of her branches. And so you can see, you can use these sliders to change and update data, but you couldn't type in, say, a number. So I'll jump over. This is like a demo of the config panel, how it looks now, and it's also linked in the enrichment blog, I think. So now you can like type in numbers and or change it with a scroll bar. So yeah, as I was building this config panel, I realized there were aspects of it that could be abstracted away and like used for other purposes. For example, this collapsible card is really a bootstrap card. So you can take that away and put different things inside of it. Having different things be collapsible and expandable, those could also be put into different modules. So that's why I have an example of most of those on this prefab demo site. Some cool ones to kind of point out, I won't go over in detail, but you can add different icons from this Font Awesome library pretty easily. Or if you need a modal to pop up, you can add that as you wish. But I'm gonna just quickly go over like how to insert a card into your web app. So that can either be like a plain card or one that's collapsible. And also these cool code blocks that you can put your code in, and then this library called highlight.js will highlight it syntactically based on the language you choose. So I'm gonna hop over to my text editor. And this is just a project that, like when you start out, if you make a cookie cutter project like Matthew's gonna talk about later, this is just in the web cc file, .cc. So I'm going to have to include the prefabricated elements that we talked about. So that would be the card and the code block. Oh, and then I also thought I would mention like the loading modal that will show up as your page is loading, but the content isn't ready yet. Yeah, so we can start with just like a plain card that doesn't do any of the fancy collapsing stuff. You would initialize it using temp prefab card. And then let me hop over to the card class real quick, because this one's a little bit complex with the constructor. If you pass it no parameters at all, you will get just a plain card, and then Empirical will create its own ID for you. If you want to specify its own ID, you'll have to fill in that like the state is either none, so it's going to be a static one. It's going to be able to be toggled open and closed, and the default will be open or the default will be closed. And then if you want to show glyphs, those are the little triangles in the header that will like toggle up and down based on the state of the card, and then your ID if you want to specify a certain one. But for now, I'll just have Empirical make its own ID for us. So I'm going to stream this new card into the doc. And then we can start loading in our data that we want to put in there. So and we can do that with the add header content. And so you can put just plain strings in there. Like this. And then you can also add content to the body of the card with A more interesting or more, yeah, I guess I'll say interesting example could be a card that is collapsible but starts out closed, but does not have the toggle icons in the side. So this way we'll have to define like each of those parameters in the constructor from the class that I showed you before. So again, we'll grab the card, create a new one. So, and I created an enumerated list of values for the state of the card, so it will be unique to just this class. So we'll say closed. And we don't want the glyphs to show, so I'll say false for the second parameter, and maybe we do want an ID called closed card. Again, we can stream that into the doc. An interesting way we designed this card class is that for the header content and body content, it doesn't have to be a string that you're streaming into it. You can stream other web elements. So say we want to, have a div that has whatever content we want in there. So we need to import that from web first, because that's a fancy tool, web tool that we can use. So now we can say emp web div. I'm not going to give it a ID. I'll just let empirical create one there. And then we can stream in and here. So now we can add content, and then we'll just put body in there instead of a string literal. And then what else?
I think on line 8, you need a .h at the end.
You were right. Yes. Thank you. And a code block. So with a code block, you have to know what you want to put into it first. So we'll put it into a variable, a string variable, and we'll call it our code. And I'm going to do the string in this way so that I can just put in what I want and not have to do like line breaks or like \n. But you could also just put a regular string in there too. Okay, that should be good. And so to use the code block, we do emp prefab code block. And so the first parameter is going to be what you want in the body of the code block. So in our case, it's called our code. And then the second parameter is a string with the language that you want it to highlight as. So in our case, we'll do C++. On the website, there's a link to like all the options for languages you can choose. You can do HTML or WebAssembly or like Python, JavaScript, other things like that. So we'll add this code block to our doc. And then one thing to note with the code block, since we're using this external library called highlight.js, we have to import that into our HTML file. So I'm just going to pull the script from, this is just the demo site. And I'll just add that here at the bottom of our HTML doc. Also, to use the prefab elements, you'll want to include a link to Bootstrap 4.5 or higher. Also, I've created a styling, like a default styling for these prefab elements that you can link using this reference. It's also on that demo site. Oh, and then the final thing we can add is a loading modal, which kind of grays out the whole screen. I'll show you real quick. And then it like waits until the page is done loading and then you can see your stuff. But the important thing with that is you'll need to include this script right after the body, the opening body tag of your HTML file. So we'll put that right here. Actually, I put this in the wrong spot. That was the highlight.js stuff. I'm gonna put it at right before the ending body tag. And then since this example is quite small, this loading, oh wait, no, I need to close the loading modal first. So prefab. This will tell the browser that you're done with it, with the loading modal, and it can close. Otherwise, it will run for a set amount of time. I think it's 10 seconds and then close automatically. But then, like as I was saying earlier, this is kind of a small example, so it's not going to take a long time for this content to render. So I'm going to like simulate time passing just so we can see the loading modal in our example. So this you wouldn't normally need to do this. These includes. And then, so right after we're done loading, we'll just make some time pass. We'll just do it for 2 seconds, pausing.
Oh, I think the STD at the front of line 44. Oh, nice.
Thank you. Okay, so now in my terminal, I've already sourced Enrichment, and I'm in the directory of our project. So I'm just going to make web, and hopefully things will compile correctly. This usually takes a couple seconds. Cool. Expected parameter declaration. I'm gonna check the header.
Should there be a comma after collapse before the close? Oh no, it should be a dot, right? it shouldn't just be a space, I think.
You say a dot here?
Maybe. I'm not sure. I didn't really get a chance to properly see the code, but it shouldn't be a space, that much I know.
Oh, maybe it's supposed to scope it.
Also.
Yeah. And I think there was
You're
somewhere
right.
where you had 1 colon instead of 2 colons that showed up in the
Yes, right here.
dot. It's like amp where, yep, there it is. Yep.
Let's see, and it might not like, well, we'll see if that fixes it.
Yep.
Test it again. Oh, I didn't save it.
While this is compiling, do you want to switch over to that prefab demo page and just walk people through kind of like just all the different stuff that's in there?
Sure.
Like a speed tour? Oh, wait, no, it
Okay.
compiled. Okay, never mind. It looks like it compiled already.
I think we're good. So I'm going to run our local server and we can test it out. See how it looks. So here's our loading modal. So yeah, this collapsed, however, just click on it because we decided not to allow that. But this one will open and close. It doesn't have the little arrows up and down over here because we told it false. And here's our code example. And it even, shows a little bit for the comments, just so you know at first glance that that is a comment. I can go over, I guess, real quick, a couple of these that I didn't go over. So this like toggle switch is like a checkbox that you can like do on or off, which is kind of snazzy. I think so. This loading icon, it's just it's gonna like show the loading thing for as long as you have it on the page. There's no like it's gonna shut off at a certain time, like this loading modal was. This comment box, if you shrink the screen, there's an option to add content only for small devices, if that's something you'd want. And then this collapse, like you can make different target areas on the page appear and disappear. But yeah. Like these cards, you can see like we could put in a code block, we can put in other cards, we can put in any of these other prefab elements. That's how I built this part of the page. So are there any questions? I know that was really super quick run through.
I have a quick question.
Yeah.
Has this stuff been merged into the master branch? Like, is this like, can we use this as of today, or is this something that is going to be merged?
No, we're still working on the tests of it. So hopefully within the next week or two that we'll be able to merge it back into master.
Okay, cool.
And I can let you guys know when that happens.
I guess a question that I have is what kind of do you see other things that would be exciting to have as prefabricated elements to like add to this collection?
Yeah, I think really anything that's built out of web tools can be broken down and it made into a prefabricated element and added, which I think would be really cool to see other things in the future. I know that in the past we've talked about adding like a little panel that would show people who contributed to a particular site and links to how to connect with them, or like another panel that would show like what all went into, like all the libraries that went into a particular project. So yeah, I think it's definitely lends itself well to adding stuff in the future.
Awesome.
Well, thank you. I'll pass it over to Dylan, maybe.
Yeah, I think he's, let me just double check. Is he next on the list? Yep, he's next on the list. All right. Dylan's been working with Austin on some tools that will work in a similar way where they'll hopefully be able to provide like a high-level API to help developers give users an interactive tutorial of their page, so that as you build kind of more complicated web apps, you can really easily onboard new users or general audience users to help make your web apps more accessible and usable. And as part of this work, they've discovered some like serious shortcomings of Empirical's fundamental designs. They've also been working on kind of figuring out how we can either work around those or how we can potentially restructure the fundamentals of Empirical in order to be more dynamic for these kinds of projects. All right, I'll hand it over to Dylan.
All right. Yeah, so, and just disclaimer, me and Austin were working furiously on this morning because we're having this weird issue where it works fine for him, but it's buggy for me. And so yeah, it's not as good as it will be, but you can see the basic functionality. So I'm going to share my screen. Okay, so first I'll just show you, this is our example app that we've been working on. So it's basically a to-do list. So, you can add a task, add another one. So yeah, you can like rearrange these. You can complete a task, you can delete it. And that's about the extent of the functionality so far. So now, if we wanted to make a tutorial for this, well, first I'll show you, it helps to like be able to visualize what a tutorial is. So this is basically, you can think of a tutorial in our library as a directed graph. So in this graph, the nodes are what we're calling states, and the edges between nodes are what we call triggers. So a state would be something like, you're waiting for the user to do something and you want them to do a particular thing. And the trigger would be the actual action that the user does to get to the next state. And a tutorial doesn't have to be linear. It can have branches or even cycles if you wanted to. And so we have there's just one kind of state, but there are multiple types of triggers. So right now we have two. One is a manual trigger, which you just trigger manually in your own code. And we also have an event listener trigger, which listens for an event on a web object, like a click or a hover, something like that. And you could even have multiple listeners going between states. And we've also designed it so that you can design your own custom triggers. So that's the basics. So let's actually take our web app here and make a tutorial for it. So I've already got the code. It's just commented out. So basically the first thing you want to do is create a tutorial object, and you're just going to pass it for now the doc, which is hooking into the empbase div. And then down here in main, we're going to put together most of our tutorial code. So you see this, let's see, get rid of this. We have the start button down here. It's going to start the tutorial. So we'll just hook that up to a function that will start the tutorial. To start it, you just call tutorial.start at whichever state. And so first thing we're going to do is create the 4 states of our tutorial. So we just call tutorial.addState, and then each state has to have a name. So you just name them. So the first thing we're going to have the user do is add a task. And then the second thing is we're going to have them complete the task. And then the third thing is kind of dumb, but just to illustrate the event listener functionality, you're going to hover on the tutorial button. And then the final state is the end state, and that'll just be where the tutorial ends. So next, what we'll do is add our triggers and visual effects. So I didn't mention before, but tutorial also has visual effects. So these are things like, you know, altering the CSS properties of an object, or adding a popover message, or adding an overlay, and you'll see what those do. So to add manual trigger, you call tutorial.add manual trigger, and you're going to give it the 2 states that it goes between. So this manual trigger will start on add task, and when we trigger it, it'll move to the complete task state. And then optionally, we can give this trigger an ID, and that would only really be relevant if you are planning to remove the trigger, but I just added an ID here so you can see. And to the add task state, we're also going to add a popover effect. So this is going to be basically a message bubble that displays a message on the particular widget that you pass it. So here we're going to put a message bubble on our input widget, which is where you enter the task. And the message is going to say enter your task here. And this is just our ID for this popover effect. So then additionally, just for some additional visuals, we're going to add an overlay effect to the state add task. And it has some default settings, so we don't have to pass anything to it. And then finally, we want to basically pop out our input widget to be above our overlay. So here we're adding a CSS effect to the input on the state add task. And here is just the property and the value that you want to set. So we're setting z-index to be 10,000, so it's above the overlay. And then this is just going to be our final trigger to get from the state hover to the end state. So you'll just have to hover over the start button to finish the tutorial. So for the, we've defined how we get from add task to complete task, and we know how to get from hover to end, but we haven't defined how to get from complete task to hover. So to do that, we can't put it down here because in order to complete the task, you're going to have to create it first, so it doesn't exist yet. So we're going to have to add a little bit of code into our, this is just the function that adds the task after we hit enter in the text box. So down here, we'll add this code that basically says if our tutorial is active, then we'll check if the current state is add task. So if we haven't progressed yet, then we're going to add another manual trigger to our state complete task. Wait, what did I do here? Okay, so yeah. So okay, yeah, sorry, I confused myself. So we're adding manual trigger to get from complete task to hover, and we're calling it complete task trigger. So that will basically add the trigger that's going to wait for us to trigger it when we click on the check button to complete the task. And then down here, we're saying fire trigger. So this is the function that fires a manual trigger, and we pass it the ID of the trigger. So when we've added a task, we've completed this step, so we fire the trigger for the add task trigger. And then, let's see, there's one more thing. Yeah, so we didn't actually fire the complete task trigger. So we'll do that up here in our onComplete task that fires when we click the check button. I know that was kind of a lot. Does anybody have any questions so far?
I'm just curious what CSS library you're using to do the styling. It looks really good.
Oh, I didn't use anything, actually.
Oh, wow.
Yeah, it's just vanilla CSS. Although I am using a library called Sortable.js for the drag and drop tasks.
Ah, got it.
So there's that. But yeah, so is there any other questions? All right, so if I've done everything correctly, we should now be able to run this and see our tutorial happening. Compile. Refresh, so when we hit tutorial, you can see our dark overlay showed up and our CSS effect took effect to bring up the z-index of this element. And this is our popover effect where we enter the message. So now we can add our task. And that step got completed. And now we haven't added any particular visual effects to the next step, but it's expecting us to click this button. So that step has now been completed. And our final step was to hover over the tutorial buttons. So here we go. And we get an alert saying tutorial complete. And that's basically it. So that's not all the functionality that we plan to have, but it's the basics. Do you guys want to like take a glance at the tutorial source code?
Yeah, and it would be really cool to hear about some of the challenges with respect to how empirical is specifically designed and how the tutorial needs to interact with it and stuff. Like some of the difficulties too.
Okay, yeah, so here's our source code. It's 700 lines, including white space. So this is the base trigger class. Yeah, it's not too interesting. It has I didn't mention that every trigger has a manual fire capability, so if for whatever reason you need to do that, you can. Yeah, it just has basically functions to apply the trigger and deactivate the trigger. It basically stores a map of states that it goes between, because you can reuse the same trigger to go between different states if you want to. So yeah, that's about it. This is just a console trigger that we're using for testing. Here's the event listener trigger. Basically just takes the widget and, you know, applies the event listener. And I didn't mention this before, but we had to alter the listeners class in order to have this functionality, because before the listeners would only allow you to have a single listener on each widget. So we had to alter it to allow multiple. So that was one of the first things we did. And here's the manual trigger, which basically does nothing. Here's the base visual effect. It's kind of, let's see, add state. Yeah, basically just tracks what states it applies to.
So can you talk a little bit more about what the set of states is? Is that like a set of attributes that are all applied at once, or is that like the steps that it'll go through?
So, I mean, conceptually, a state, I can find the class here. Like I said, it's a node in the graph, basically, and a state basically just stores a set of triggers and a set of visual effects.
Oh, I see. So the state corresponds to the node, and then you tie on the visual effects and the triggers to that.
Exactly.
Okay.
And then you have this function to activate the state, because obviously it can't be activated right when you add them. It has to wait for the user to get to the right state, the right step in the tutorial. Let's see, what didn't I look at? Here's the popover effect. So this is where we ran into kind of a serious limitation of empirical, because originally we wanted to use bootstrap popovers for this, because they were like exactly what we needed. And you know, why reinvent the wheel? But the problem was you could add them, but we couldn't remove them properly, because basically empirical doesn't play nicely with JavaScript. So if you like do something in straight JavaScript, like add an event listener or an attribute to a DOM object, empirical will basically wipe out those changes the next time the widget gets redrawn. So doing stuff from JavaScript is kind of useless in a sense. And the issue was that when Bootstrap added a popover to a widget, it would add some HTML markup to that widget that it needed to like identify, like, hey, we have a pop-up here. And so when the widget got redrawn, all that stuff got wiped out and we couldn't remove it. So we were basically forced to create our own popover class. And it's like, it's decent for now. It's not, might never be as good as the Bootstrap one, but it has the basics for now.
What's doing the that like cool little bouncing effect?
Yeah, so this is the popover. Mm-hmm. And right now this is just styled in our CSS to have an animation. Mm-hmm. So yeah, that's not like built in to the library yet, but we plan on it.
Cool.
And it's the overlay effect, which basically just adds a div. And this is why we had to pass in the doc when we created the tutorial, because it needs somewhere to add the div mm-hmm. that represents the overlay. So nothing too interesting there. And finally, we get to the actual tutorial class, which kind of brings everything together. So it stores 3 maps. Basically everything is essentially stored in the tutorial. Like it stores the actual pointers to the triggers and the visuals. And state only stores IDs. So internally, every single trigger and visual has an ID. So when it needs to get like a trigger, the state will just come. It just asks the tutorial class. So there's a whole bunch of functionality here. We got some like utility functions. Check to see if it has this trigger or this visual. We have the function to start and stop the tutorial. And here we have the functions that the user actually calls. So this is the add state function that we were calling.
We should probably be sure to have time for Elizabeth and Oliver, so we should probably move towards wrapping up. If there's anything at the end that you wanted to recap really briefly.
Yeah, for sure. I don't think so. There's really nothing too interesting down here. Yeah, I mean, that's about it. If anybody has any quick questions.
Yeah. Well, while people kind of think of questions, I just wanted to comment that some like the custom CSS stuff that you've got going on here is really cool, especially that popover class that you ended up having to kind of work around to build your own. And I'm thinking maybe if the stars align and if there's time and that things work out, that it would be really cool for you to coordinate with Sara after she gets like the structure of the prefab directory merged in to like see if we can refactor some of these custom components you built that might have like more broad applicability and like put those into the prefab library as well.
Yeah, that'd be really cool. And credit goes to Austin. He did most of the work on that popover, and he did some dirty work in the empirical source to make it work.
He's a magic worker.
He is. All right.
All right, do we have any other questions? All right, then let's move on to Oliver and Elizabeth. They've been working on, I think, like the nominal organizing topic of their project was the D3 wrapper, but to make that all work, it sounds like they've been doing some really intense stuff, making like the piping between C++ and JavaScript, like fixing that up, and also building out the web testing system so that we can like actually verify and we can keep our giant burgeoning web tools in a maintainable state. So I'll hand it over to them.
Thanks. Yeah, so we've been rewriting and updating the D3 wrapper, but we're not, D3 is a JavaScript visualization library. So as Matthew said, we've had to jump between C++ and JavaScript a lot during the process. We're not really going to talk about how to use D3 or the D3 wrapper today. We will show some examples of what you can do with it at the end, and feel free to reach out if you want to learn more about it just on Slack. But we are going to hopefully show some helpful code snippets if you feel the need or have to jump between C++ and JS if you're making a web app or doing a project like that. So I think Oliver's going to go.
Yeah, so we just put together this little file that kind of displays a bunch of the different functionality that you might want to do between passing stuff between C++ and JavaScript. So Elizabeth is going to talk through kind of the first half of this, and then I'm going to talk about the second half. And we're kind of just going to describe how each of these like basic use cases would work in your code.
Yeah, so the very first thing that you might want to do in the middle of your C++ is just insert some JavaScript, like just have a block of code that's JavaScript. And for that, you can use this EM-ASM block. Basically it tells Emscripten that, you know, the part in this block is JavaScript, and so you have to convert and make it work with the C++ that's around it. So you can literally just type in EM-ASM and then in the block, plain JavaScript. And if you want to pass in variables to that, you can add them like this little X at the end of the block, and then reference them with $, and then the index of the variable. So since X is the first and only variable that we have there, it's $0. And an important thing to note is that those variables won't stick around if you have multiple EM-ASM blocks. It's just local to that one block. And a common thing is to assign it to a variable name so that you don't have to keep on saying $0, $2, 3, whatever, if you want your code to be more readable. Yeah, excuse me, but this EM-ASM block doesn't return anything. If you want to return an int, you can use EM-ASM int, which is the second one there in the snippets. So there you just set it to a variable. It has to be an int since you're returning an int. And here we're just returning 10 to show an example. Should we show the examples all at the end, or?
Yeah, I'll just show them all at the end because I have to switch between my Chrome and then this.
Sounds good. And then a double is very similar. So you just use EM-ASM double, and that macro will return a double if you set it to, yeah, a double variable. And then strings are a little bit more complicated because you have to convert them using this UTF-8 to string function. Basically, I guess that they're stored in different formats in JavaScript and C++. That's my understanding of it. So you have to pass them in with this .c string on the variable name when you pass it into the EM-ASM block, and then use the UTF-8 to string function inside. And if you are passing a string the other way back into C++, there's a similar function called string to UTF-8 that you use. And then this is an example of the pass string to C++ function that we wrote while we were rewriting the wrapper because we found that it would be very, very useful. Basically, this goes the other way. So if you have a string in JavaScript that you want to access back out in the C++, you can use this function, and it'll take care of all of the messy stuff like the buffer and like memory allocation, all of that gross stuff, which you can see below in the old way section. And to access it after you use the pass string to CPP function, you just set a variable to emp : pass string to CPP, which is what it gets stored in after you call the pass string to CPP function. So this really helped us out a lot with cleaning up the code and making it less repetitive. Yeah, so that's how you can pass data between the two sides a little bit easier, and Oliver is going to talk about functions and other cool stuff.
Cool. Yeah, so if you want to have functions that you can create on one side and then call on the other, there's two different ways to do that. So if you want to call JavaScript functions in C++, what you can use is this emjs macro, which I think is new at the time of, or didn't exist at the time of the old wrapper. So it wasn't really used, but essentially what you would do is, and I'm going to uncomment out this line of code because essentially what this em_js macro does is going to create a function based on the parameters you pass it. And essentially for this to work with this example, we just needed this function to be created outside of main, which is why it's commented out. So it exists elsewhere. But essentially the first thing you would pass in is the return type. The second parameter you pass in is what you want the function to be named on the C++ side. The third group of parameters are whatever your input parameters are for the actual function itself. So here we want to multiply two numbers, so we're passing in an int x and an int y. And the fourth thing you pass in is the actual body of the function. And so the body of the function is written in JavaScript. Here we're just doing a super simple multiplication. So once you called that macro, the multiply function with those parameters will be created on the C++ side. And if you see on line 205, you can call that function once it's created on the C++ side. If you want to go the other way, so if you want to call a C++ function inside of JavaScript, you can use the JSWrap function, which exists inside of its own header file. And there's a little bit of weirdness with the deleting of the function, but essentially what's important is that when you call emp::JSWrap, you pass in a function as the first argument. And again, we've created this function multiply pair outside of the scope of main, just so our compiler doesn't complain. But multiply pair is doing the exact same thing as above, it's just multiplying two numbers. So the first argument you pass into JSWrap is just that function. And then the second is what you want that function to be called on the JavaScript side. So this line of code will create this function that you can then call in JavaScript. What's happening here when we're assigning this to the result of this JSWrap to an ID is that we're just keeping track of the function ID so that later on line 221, if we want to get rid of that function to clean up our namespace, we can use the ID to do that. So essentially, the multiply function ID, you just pass in the JS delete and it'll take care of all the stuff behind the scenes to get rid of that function. So once you've JS-wrapped this multiply pair function, you can hop into an EMASM code chunk, and if you use the EMP namespace, you can do EMP dot and then whatever your function's called, and then access it based on how you wrote it in C++. So EMJS is going from JavaScript to C++, and then JSWrap is kind of the other way around. And this is definitely super helpful for testing if you want to have stuff that you write in C++, but then you call in JavaScript at a very specific time. It helps to deal with the asynchronous nature of JavaScript, so you're not kind of hopping between C++ and JavaScript, but you don't know when stuff is being called. The next group of things I'm going to talk about are if you want to pass in more complex data types than an int, double, or a string to JavaScript. So there are a couple of helper functions that have been written in the JS utils header file. And the first is pass array to JavaScript. So it does exactly what it sounds like. If you create an array on the C++ side and then pass it into the emp::: pass array to JavaScript, what that does behind the scenes is store that array inside of this emp_i dot incoming array. And so once you've done the pass array to JavaScript, this array is now exists on the JavaScript side, and you can access it from inside any code chunk. And this emp_i incoming array will exist no matter what like EMASM chunk you go into, and unless you call it again, and then it will reset what the array is. Yeah, essentially the incoming array will persist throughout different code chunks because it's in this em_i namespace or library. And if you want to go the other direction, you can use the pass array to C++. So it's very similar, but what you do is you hop into JavaScript from EMASM, and you store whatever your array is inside of emp::I outgoing array. And once you've done that, you can use the emp pass array to C++ on some C++ array, which you just declare here, and you can then use the pass array to C++, call it on the array, and then it will have populated the array from JavaScript on the C++ side. Now, one thing to note when you're inside of an EMASM chunk is that you'll get some nasty, nasty errors if you don't surround your arrays or dictionaries or objects with parentheses. Not sure why, but if you're getting bizarre errors where your whole piece of code just goes haywire, it's probably because you haven't included these parentheses. So the last bit of functionality that might be useful to use is if you want to pass a map to JavaScript. And essentially this works the exact same way as pass array to JavaScript, except you create an EMP map on C++ side, you use pass map to JavaScript, and this will be emp::: pass map to JavaScript. It's just not merged in yet, so I have the function at the very top of this file, which is why it's not emp::: But it will look the exact same as pass array to JavaScript, and if you want to access it on the JavaScript side, you would use emp_i dot incoming map. And yeah, it works the exact same way. And another little bit of cool functionality is that if for some reason you just have your keys and values stored in arrays and you don't want to make a map yourself, you can just pass in the keys and values separately to pass out to JavaScript, and it'll deal with it for you, and you can access it the same way. I know that's kind of a lot of different functionality. Are there any questions on how you would use this, or when a good time to use a specific thing would be?
I've got a question. How does this deal with array links? Do you have to keep track of that like yourself in terms of like if you had your outgoing array only have 2 elements in it, but your emp array had like 3 elements? Like, would it crash, or would it just be weird, or?
Oh, so you're talking about the pass rate of C++?
Yeah.
I think it would probably crash. I haven't tried it with differing amounts. I imagine that it would not take very kindly to that, but yeah. So I think you do have to explicitly declare /note how long the array is.
Got it.
But I do know that when you're passing arrays into JavaScript, you can also pass vectors in. So I wonder.
Oh, cool.
I wonder if the pass array to C++ will also deal with vectors in a similar way. I imagine it will, but I'm not sure. Oh yeah, and I can quickly just share my Chrome window because we're going to show some D3 things really quickly.
Yep.
And to prove that that code actually works. So here are just all the console. What happened? Right. So here are all the things that we printed out from our console. We have, and again, if you stdc out or console.log, it'll all show up here when you end up running your code. So we have our multiplying working correctly, our strings working fine, our ints and our doubles. And this is the array on the JavaScript side. This is the array being printed out from C++. And then we have these 2 maps that we passed in. So yeah, is there any other questions about that before we talk a little bit about D3 and then pass it on to Matthew?
I think we're good to show some D3.
Cool. So part of the purpose of making this new D3 wrapper is to wrap some like pre-existing visualizations or like some visualizations that you can just use right out of the box, because D3 has a little bit of a learning curve to use, whether it be C++ or JavaScript. So an example, we're just going to show a few examples that have already been created with D3 to kind of motivate why you'd want to use it. But this is something that Emily made that shows you different interaction networks, and these are made with D3. And so something that we might have would be just like a prepackaged version of this that you could use. Another thing that Emily made is this really cool tree visualization. And this is made entirely with D3. And I think the old version of the D3 wrapper has kind of this built in where you can plug in your data, and it will auto-generate this with all these cool tooltips and the ability to filter by color, which I'm pretty sure is working, but haven't played around with it too much. Yeah. So yeah, we don't have stuff currently with the D3 wrapper that we wanted to show you today, but we'll keep you updated as we have more stuff and like prepackaged visualizations for everyone to use.
All right, any questions? I'm just going to switch over to, how do I, all right, okay, there we go. All right, thank you, Emily and Oliver. So in the really short amount of time that we have left, I'm just going to really quickly give an overview of how we can deploy how we can deploy web apps built with empirical really easy using this cookie cutter framework. So the cookie cutter, I'll link this on the site, but cookie cutter lives at devosoft/empirical, no, it's cookie cutter empirical project. And so the high level takeaway that I want you to leave with is that the cookie cutter makes it really easy for you to have a GitHub repo where when you push things up here, it spins up Travis, and Travis will run a job that will run the tests on your code to make sure that your code is still in tip-top shape. And then, crucially, it will, once that job is complete, it'll actually compile your web page and push it to this branch. So it'll push code with the compiled version of your website back to this GitHub pages branch. So it'll push your HTML and your JavaScript, and then GitHub pages will be able to serve up your website automatically for you. So in this case, it'll be devosoft.github.io/cookie cutter project. Devosoft, oh, I misspelled Devosoft. And so now you always have a current version of your project always served up fresh for you, and you don't have to put any mental capacity into maintaining your deployment. And so the tricky part is you have to give some permissions in order to get this auto deploy process to work, because you basically have to store a secret code inside of Travis that will say, hey, Travis, you're allowed to push things to GitHub without me actually putting in my password. So I put a detailed kind of step-by-step here, but I thought that I would just try to do a speed run through this process just so that you can all see it in action. And then I'd really encourage you to go give it a try, and then we can troubleshoot when kind of people run into stuff in the Slack. But so the first thing I'm going to do is I'm going to I already have cookie cutter installed, so I'm going to use cookie cutter to instantiate the project. I might have to do this. So I'm just it's going to ask me a bunch of questions about my name, my email. I'll have my username be mmore500, project name, project slug. You can put in custom responses for all of these, and it'll set up your projects just the right way. Blah, 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 blah. So you can go and customize your project. And so now I have this project all set up for me. So if you can see it's personalized the project with the responses that I gave. It's called Cut Empirical Project, and it's got the description here. And so what I can do is there's some initialization steps that you can just kind of copy paste from here that will set up a Git repo. And I'm going to do most of these. And this is going to set up the external dependencies. So it'll install Catch, which we use for tests, and Empirical, which we use as a library, as subrepos. And then I'm just going to, I have this command line utility that just really lets me make GitHub repos really easily. So I'm just going to create a GitHub repo. And now I'm going to push this up to origin. So if I go to, and it's Cut Empirical Project. So now I've got a GitHub repo with kind of all the basics laid out here. And what I'm going to do now is actually go through the process of encoding and storing my GitHub key in here. So let's see, where is this? And we can, I'll come back to how you can actually run the test inside of this cookie cutter template. But so I'm already set up with Travis CI. Travis usually recognizes my repos automatically, so I'm not going to go and add it manually. But I'm going to make a new GitHub personal access token. And I'm going to call it for cut cookie. And I just have to click this repo button to give it permissions to do work on my repos. I'm going to click generate token. And I'm going to copy this token. And I'm going to paste it somewhere where I can keep track of it. All right. And then I'm going to go and I have to install Travis's Ruby gem. And so you'll need Ruby, and then you'll have to gem install Travis. But I've already got that set up. So I'm going to go over here and do this. And then I just have to change this to actually put my GitHub token there. So let's go copy this, paste that. And now this should just shove my GitHub token. Yep, it shoved it into my .travis.yml file. So if I add it, you can see it did some reformatting, but this is where it put the secret token, and it's all encrypted. And so I'm gonna go ahead and say, yep, go ahead and put that in there. Add GitHub deployment token. I need to spell. And that should be all that I have to do. So I just pushed up to master. And so if I go over to the repo, let's see. So my new commit just showed up, and I can click here and see what Travis is doing. And go check on Travis. So it started the build. And so we'll check back on this in a second, and it should just run my test, build my site, and deploy it for me. But the other thing I wanted to show off in this cookie cutter is that there's actually some tests built in. So if you cd into tests, there's some, you can see I just left this example.cc file. There's just a really simple catch test that's defined here. And so if I just make test inside of this test directory, it should just compile and run that catch test. And so the idea is that as you write your own code, you can really easily have everything you need all in place already to start writing your own tests and getting them running really easily. I don't know why it's taking, yep, so it compiled and it passed. And ideally, we would really, really like to build the web testing into the cookie cutter so that when people start off with the cookie cutter, they already have all the stuff they need in there, especially to do the really cool new web tests. Like it's all in place for people to just get off and running with. And so if that's something that's interested to the D3 team, that would be really great. I'd love to see a pull request on the cookie cutter to add that. So let's go check on the deployment. It's still doing stuff. But doing stuff. it might take another minute, and we're kind of at time. But basically, that's all that I have to do to set up. If I were to go to mmore500.github.io/cookie, or what was it, cut empirical cookie. If I were to go to this address, once this Travis build stops running, my site will just be live there. And as I push changes to the source code, it'll just continue to refresh in the background, and it'll yell at me if I do stuff that makes it break. All right. That's the whirlwind tour of the cookie cutter. I'll be sure to link it from the page for today's tutorial. And if there's any questions, there's always kind of rough edges. Hopefully that list that's on the README of the cookie cutter should give you a good start, but there's always stuff that comes up. So feel free to hop onto the coding Slack or wherever, and we'll work through kind of the deploy process. Because although there's a few steps you have to do to actually get it set up, once you have it set up, it's a giant weight off your shoulders. All right, were there any questions, or should we wrap up?
I just had a super quick question.
Yep.
Does the cookie cutter, will it update empirical for you? Like, can you pull new changes into empirical if you need new functionality that comes out with new commit?
That's a really good question. So this is finished running. Let me go to, I'm gonna delete this because this is gonna go on YouTube, and I don't want people to steal my, actually, I'm on, just a second. Hold on. Did this get pushed? Okay, so I'm gonna go ahead and delete this before I forget so that I don't have my GitHub hacked. And then with respect to your question, sorry, what did you ask again?
So like if there's new functionality, like the prefab is pushed to empirical, and I have already made a
right.
instantiation, can I pull that down?
Yep. So internally, empirical lives inside of this third party. So this is, let me actually show this one. Sorry. So empirical lives, this is the cut cookie. So this is the repo that we just made. And empirical lives in this subdirectory as a git subrepo. And so if you want to pull down fresh commits, you just have to go into that directory and then basically git pull from master and then commit the new version of empirical that you're tracking into your cut cookie git. So there's the project git, and then there's like the sub git, which tracks in a specific empirical version. So you can really easily pull down new versions and update to specifically track the new versions to get new features. And you can also set it to track branches kind of other than main. So if you need to set it up to like track your development branch, you would just use, let me go back to the list of instructions. You would just change -b master to -b whatever your branch name is. And
okay.
So you can totally get this set up to track your development branch. And then you can switch it from the development branch to master once your stuff gets merged in.
Okay, cool, awesome. That's super handy.
Yep. Are there other questions? All right, let's see. I'm just curious. GitHub is supposed to probably have deployed it by now. So let's see if we can go see it. And then I'll let you all go. Hey, it worked. This is the thing that we just made, and now it's all deployed for us. And by default, it sets up this landing page for you. And then when you click, it'll go to your project where it'll actually run whatever stuff you've got set up. All right, let's end it there. But if you have other questions, feel free to follow up on the Slack. and I'll try to get all the code snippets and links from today posted. This has been really cool. All right, thanks everybody.
Thank you.
Thank you. Bye.
Thanks. See ya.
Bye.